Okay, so at the end of this section, we can also discuss two variants of the recurrent neural nets and how to apply them to deal with some natural language processing problems. The first variant of the recurrent neural nets we want to discuss here is called bidirectional RNN, or BRN for short. Before we mentioned that we can use both the CBAL or the skipgram for learning the embedding vectors of the words, right? And both of these methods will utilize some of the information from the surrounding context, both ahead as well after the current words for learning the embedding vectors, right? So they can capture the patterns from context both forward and the reverse directions, actually in learning the embedding vectors. We also mentioned we can use recurrent neural nets to infer or to do the generation of the next word, right? And to learn the embedding vectors as well. However, when we learn the embedding vectors for the words with the recurrent neural nets, what we can get, learn the embedding vector is actually in a sequential way, right? For example, if we learn the embedding vector for the noun, what we can have actually is covering the words before the noun, right? We don't know what are the words after the noun actually. And in other words, compared with the CBAL as well as the skipgram methods, this recurrent neural net seems to be, weaker, in capture the information for learning the embedding vector for the words, right? So, to address this kind of problem, then we have to introduce another variant of models for the recurrent neural nets. It's called bidirectional recurrent neural nets. What does this mean? Before, if you still remember, when we try to build a recurrent neural nets given the inputs, right, we can build this kinds of recurrent neural nets in a chain way, right? In the same order as the input words. Now here we have some words that inventors have long dreamed, something like this, right? We feed them as inputs for recurrent neural nets. Before, we just feed them into the recurrent neural nets in this order way, in a sequential order way, right? And also, for the chain of the hidden layers, we also follow in the order of the input words, right? From the left-hand side to the right-hand side. This is the conventional recurrent neural nets. In other words, when we learn some words embedding vectors like noun, we can capture all the information from both noun as well as the words before it, right? In learning its representations. We can only capture the patterns before the current words, actually in learning its embedding vectors. So we may want to consider to further extend its recurrent neural nets to capture the words probably from the words which are after or behind the known words. Right. So to achieve this kind of target, we can extend the recurrent neural nets to the bidirectional recurrent neural nets. In this page, we show you with the example for the bidirectional recurrent neural nets actually. So you can see, for the bidirectional recurrent neural nets, we have two neurons in the hidden layer, right? However, these neurons in the hidden layer, actually their connection, the direction is very different. So we have two directions at the same time. Given the inputs like x0, x1, x2, until xi, right? We have one of the hidden layer of the neurons to be in the same order as the input words from left-hand side to the right-hand side. This is chain, right? It's chain. Given the words as well as the neurons or the hidden neurons before it, we can learn the embedding vector for the neuron for the words, right? Actually, besides from the left-hand side to the right-hand side chain, we also have another chain which is from the right-hand side to the left-hand side instead. They will also accept the inputs from the raw inputs like x0 until xi. At the same time, they also receive the inputs from the neurons which are after it. Now for this neuron, we will receive the input from the neuron after it as inputs, right? This one will also receive the input from the neuron after it. It is in the same architecture as this one, however, the connection direction is reversed. It's reversed, right? You can see we also have this S0, SI. This is S0 denoting the starting dummy input for the first hidden neuron, right? And this SI denoting some dummy outputs which will be useless actually. Similar for this S0 prime and SI prime, right? This will be a dummy input for the first hidden neuron, and this one will be the output for the last hidden neuron, which will be useless actually. Here I mentioned this dummy input. They will be assigned with some meaningless values or zeros, right? For example. So when we do the prediction or do the generation of the next word based on the inputs, what we can do is actually to infer some outputs based on both the hidden representation by both the, from the left-hand side to the right-hand side is kind of chain neurons as well as the reverse direction neurons. So by integrating these two neuron hidden representation together, then we can infer the output we want to predict actually. So you can see, when we build a recurrent neural net in this way with bidirectional, actually it's embedding vectors we can learn from this input words, capture both the words ahead of it as well as after it, right? Probably we can take this one as example. Now for the known, when we learn the embedding vector for the A, we can capture all the information before it, like inventors have known, right? And when we learn the embedding vector for the A prime is neuron, we can capture all the neuron, then we can capture all the information after known, right, as input for learning the embedding vectors. So by integrating them together, we can infer the output, right? It will capture both the information ahead of it and as well as after it, right? So this is a way we can extend the recurrent neural nets to capture the information from the context both before and after the current words. Okay, so the bi-directional recurrent neural nets has been extensively used in the real-world application projects as well as in academic projects. So you may wonder how can we implement this kind of models in coding. Actually, PyTorch has provided with this bi-directional recurrent neural nets already. So if you go to the PyTorch recurrent this kind of class, we have one variable which is bi-directional. If you assign a variable with a true value, then it becomes bi-directional recurrent neural nets by default. So the coding part is very trivial actually. You can just call this a recurrent neural nets in PyTorch and also change this bidirectional to true, then it will be building a bidirectional recurrent neural nets for you. Okay, so the coding is very easy and you can also try to play with it if you are interested in it, right? Now you can build one bidirectional recurrent neural nets for the document classification in your project stage 4, right, as example. Yeah, and you can play with it to see its performance.